Ever wondered how the metal that can survive the heat of a star ends up in your power drill, a light bulb filament, or even a wedding ring? Stick around as we trace tungsten from a raw ore deep underground to the high-tech products you use every day. Tungsten occurs mainly as wolframite, Na₂WO₄, and scheelite, H₂WO₄. The biggest deposits are in China, Russia, Canada, and Portugal. Depending on depth and terrain, miners use either open pit or underground tunneling. In hard rock mountain regions, blast and haul cycles break the ore loose, which is then loaded onto trucks for transport to the processing plant. The ore is first crushed in jaw crushers to fist-size pieces, then ground in ball or rod mills to a fine sand-like consistency. This increases the surface area for the next separation steps. Because tungsten minerals are about 1.5 times denser than the surrounding gangue, shaking tables or spiral concentrators cause the heavy particles to settle while lighter rock is washed away. For finer particles, collectors such as fatty acids are added to make tungsten surfaces hydrophobic. Air bubbles lift the tungsten-laden froth to the surface, where it is skimmed off. The concentrated tungsten minerals still contain iron, manganese, calcium, sulfur, and oxygen. They are leached with either sodium hydroxide, NaOH, at 150-200 degrees, producing sodium tungstate, Na₂WO₄, and insoluble iron manganese hydroxides, or hydrochloric acid, HCl, which dissolves the tungsten as tungstic acid, H₂WO₄. The resulting solution is filtered to remove solid residues. Adding a strong acid, often sulfuric acid, to the sodium tungstate solution precipitates tungsten oxide, WO3, as a yellow powder. The oxide is washed, dried and calcined at 500 degrees to drive off water and any residual acids. Hydrogen reduction. The WO3 powder is placed in a tube furnace and heated to 800-900 degrees C, while a flow of hydrogen gas reduces the oxide. WO3 plus 3H2 yields W plus 3H2O. This yields a fine gray tungsten powder with particle sizes ranging from 0.5 mm to several microns, depending on temperature and gas flow. Powder consolidation brings the fine tungsten powder together into a solid form, ready for further processing. Because tungsten melts at 3,422 degrees Celsius, conventional casting is impractical, so the powder is sintered in vacuum or hydrogen, here around 1350 degrees Celsius, to form a dense billet. First, the powder is cold-pressed in a die at roughly 200-300 MPa to form a green compact. Then it's sintered just below melting, about 1200-1500 degrees Celsius, where particles bond by solid-state diffusion, producing roughly 95% theoretical density. The sintered billet is heated to about 1,200-1,400 degrees and worked, rolling, forging, or swaging, to refine the microstructure. These hot working steps align grains and increase tensile strength and ductility, making tungsten suitable for high-stress applications like cutting tools and aerospace components. One iconic use is incandescent filaments, where thin tungsten wire glows under extreme heat. Thin tungsten wire is heated to about 2,500 degrees C in incandescent filaments. Tungsten carbide, made by carburizing tungsten powder, powers cutting tools, drill bits, and wear parts. In aerospace, tungsten serves as counterweights, radiation shielding, and high-temperature engine components. In medicine, tungsten appears in X-ray tubes, collimators, and radiation therapy equipment. Worn carbide tools and scrap are crushed, roasted, and chemically processed to recover tungsten, cutting the need for fresh mining. Ongoing research examines tungsten alloys with rhenium, molybdenum, and nickel to improve machinability and ductility. Several challenges remain: supply concentration, costly machining due to hardness, and brittleness under sudden impact. Most tungsten comes from a few countries. Machining often requires diamond-tipped tools, and pure tungsten can fracture, so alloying is essential. From dark ore to precision tools and glowing filaments, tungsten's journey showcases advanced materials engineering. From a dark, dense ore buried in mountainous rock to the gleaming filaments and ultra-hard tools that power our modern world, tungsten's journey is a masterclass in materials engineering. If you have any questions or comments, please leave them below. Your input matters. Share your ideas for our next video in the comments, and we'll recognize your contribution. Thanks for joining us on this exploration of the fascinating stories behind everyday things. Don't forget to like, subscribe, and stay tuned for more captivating content. Thanks for watching, and if you want to learn more, click the next video right here.